This should be a review of things you already know, but I just want to make sure we had a conversation about solving and graphing inequalities in one variable. So let's go with the real basics, making sure we know our symbols. So there is the symbol that looks like this, and a symbol that looks like this. Remember that this means less than. This symbol means greater than. We also have this symbol and this symbol, which means less than or equal to. And we have this one that means greater than or equal to. Now when we actually need to graph later, we're going to need to use some other symbolism. So that we use these open or closed dots. So we use open dots if it's less than or greater than. Again, we use this open circle. Versus we used a closed dot to say we include the value when it's equal to. So these are called closed. So if I want to solve something, let's say I did this example and I said solve and graph for x. Well, hopefully you, again, the first thing you do is you almost pretend that inequality isn't there, treat it like an equal sign and just solve the problem. So we'd subtract 1 from each side. So I have 3/4 x is greater than or equal to -12. And then I need to, well, you could do it a bunch of ways. I'm going to think about the fact I want to divide by 3/4. Divide by 3/4. Oops, sorry, that's not divide, Miss Rhoda. Divide. And that means when I divide that out, I'm really doing -12 times the reciprocal. So if I cross cancel to make my life easier, that means x is greater than or equal to -16. Now every teacher has a different way they like you to graph on a number line. I'm going to show you my expectations for graphing on a number line. Obviously there should be a number line. Now if you're being an amazing A+ student, you should also include what variable you solve for on the end. In the middle, I would like the solution. I would like 2 numbers greater and 2 numbers smaller to show where it is relative on the number line. So hopefully we all know what numbers are bigger and smaller. And I tend to like to use a different color to show what's going on. So I know that I'm using -16, and since it's greater than or equal to, I used a closed dot. And I usually do it right on there because I'm using a separate color. I need the numbers greater. Hopefully we know the numbers that are greater are to the right. So this would be my graph solution of what I have up here. Let me show you something else that's kind of cool. Did you know you were born with inequality detectors in your hands? It's amazing. So if you look, my right hand fits into the symbol and the graph goes to the right side on the number line. So if you're too lazy to think about what numbers are greater or less than, use your handy dandy built-in inequality detectors, although there's one thing, make sure if you do that it's set in standard form, meaning that the variable's on the left, the symbol, and then your solution is on the right if you're going to use your inequality detectors. Let's do one more problem. What happens when it's not a whole number solution? So I'm going to do that over here. So if I have 5 times m minus 2 is less than -2. First thing you should do, obviously, is distribute, again, pretending that's an equal sign. 5m minus 10 is less than -2. Add 10 to both sides. 5m is less than 8. Divide by 5. So how on earth can I graph this? Well, that's really 1 3/5. So as I make my number line, I'm going to move it up so everyone can see better. Again, I start in the middle. Now to make sense, we should go in numerical order, so I'm going to make things, again, that are evenly spaced, bigger and smaller. So it makes most sense to go by fifths. So this would be 1 4/5, 1 5/5, but that's really 2. This would be 1 2/5, 1 1/5. So again, I notice that this says less than. Remember, less than means an open circle. Using my handy dandy inequality detector, I use my left hand and see it goes to the left side, or I can remember that's where less than is. The biggest thing I want to remind you is the beware. That's what I call it if we were in the classroom. We'd say, watch out for the beware. In fact, we'll even kind of put it in the funny Spanish, even though I know that would be cuidado, but beware. If you multiply or divide by a negative coefficient, you must flip the inequality. So again, let me emphasize that you must flip by an inequality only when you multiply or divide, not when you add or subtract or do anything else like that. So just do one example real fast. We won't graph it since I hope you got the graphing stuff in your head. That means if I have something like negative 4x is less than 8, if I divide both sides by negative 4, there's my dividing by a negative, my solution would be x is greater than negative 2. Now if it's the opposite way, if it was just 4x is less than negative 8, notice that one would not flip because I am not dividing by a negative, it's just the solution over here is negative. I hope this is a great review for you, so now you can remember how to graph and solve inequalities in one variable.